that one because how do I set that up? Which one do I write first? This one or this one? First one or the second one?
The one on the left. No, the one on the left.
Right, it says subtract this one from this one. So it's going to be x minus 6 minus 9x minus 5. Okay, subtract this one from this one. So again, the easiest way to do that one is to change my signs here, make that negative 9x and positive 5. So then combine like terms, x minus 9x is negative 8x, and negative 6 plus 5 would be negative 1. So kind of going through this section quick, but I feel like we've done most of this already. Let's do one of these. Let's do this one. So here you're putting those together in words. So you have the sum of 9 times a number and negative 2 added to 7 times a number. So first of all, the sum means we are adding, right? 9 times a number. How do I write that? 9x and negative 2. So the sum of 9x and negative 2 would be what? Plus negative 2. What's a different way I could write that? 9x minus 2. So there's a sum of 9x, 9 times a number minus 2, added to 7 times a number. Okay, so you kind of just break that into piece by piece. Again, I think we talked about those words on the first day too. First or second day. So a lot of 2.1 we have seen throughout. It's kind of just putting it all together before we go into solving equations. So let's just go ahead and jump into 2.2. 2.2 is actually solving equations. Start at the basic ones with if you have x minus 7 equals 10. So with this one, we actually have an equal sign in it. All the others do not have an equal sign in it. So it's an algebraic expression. This is an algebraic equation because it has an equal sign in it. So here you have some number minus 7 equals 10. So these you can almost think about what's a number minus 7 that equals 10. You can get your answer. What? Oh. So here, you have 2 different sides of the equation side. And you have the left side and the right side. So you have x minus 7. So to move the 7 over, you would do the opposite. So I'm going to add 7. If I do something on the left side, I got to do it on the right side to keep it balanced. So my answer is x equals 17. So the goal here is to get the x by itself. And if you have x plus 6 equals negative 5. So here, what number plus 6 equals negative 5? Again, I'm going to do the opposite. So I subtract 6 from both sides. And I get x equals negative 11. If you have something like this, if you have multiple terms in there, the first thing you want to do is get the term with the x by itself. Get the term with the x by itself, so I want to get this by itself, so I need to get rid of that negative 6. And then I have 2x equals 4. Right, this is 2 times x, so the opposite of that would be to divide by 2. Divide both sides by 2, so I get x equals 2. What about something like this? X divided by 7 equals 3. How can I get rid of that 7? We could do 3 over 1. What's happening here? This is x divided by 7, so the opposite of division is, so if I just multiply both sides by 7, these should cancel out, like 7 over 1, and I get x equals 21. So this is saying what number divided by 7 gives us 3. There's a couple of problems we'll deal with fractions today. Nobody likes fractions, so we'll figure out an easy way to do those. All right, what if you have multiple terms on both sides, though, like this? So the first thing I want to do is just look at one side, just focus on one side. So if I'm just looking at the left side, I can put the 2x and 3x together, which would be 5x. I can also put the negative 5 and 7 together, which would be positive 2. Can't put anything else together, so I'm done on that side. On the right side, I could put the 10x and 6x together, so that would be 4x. And then the 3 and negative 4 together, which would be negative 1. So now I've simplified as much as I can on the left side and the right side. Now start thinking about moving things across. The first thing I always like to do is get my x's together in one spot. You can either move them all to the right or all to the left. I think most of us usually move them to the left. So here I subtract 4x from both sides. That cancels out, and 5 minus 4 would be 1x. And now, to get the x by itself, I subtract 2 from both sides, and I get x equals -3. This line, I do this line right here for this problem, and some people like it, some people don't. You obviously don't have to do it. But I do this line right here so I can focus on one side of the equation on the left side or the right side. So like my first step was to combine everything on the left side, and then I combine everything on the right side. Then when I start thinking about moving things across, that's when I do the opposite. It's a very common mistake when you get a long problem like this, to say, okay, if I'm going to put this 6x right here with this 10x, I need to add 6x. Well, what's wrong with that? I didn't cross the equation. I only do the opposite sign when I cross the equal sign. Okay, so that's kind of why I draw that line, to help you remember that you only do the opposite if you're going to move it to the other side. All right, so here's one where you got the distributor property mixed in there. So we can't do anything on the left side. There's nothing to do over there. There's just a 7. So I wanted to simplify this right side to get going. So I get -10a plus 5. -1 times both of these would be plus 11a minus 6. So now again, let's combine some terms here. -10a plus 11a would be 1a. And then 5 minus 6 would be -1. So here we can leave the a on the right side and just get rid of this 1 to get the a completely by itself. So I add 1 to both sides, and I get a equals 8, which you could rewrite that like this. One thing I have not said is on all these problems, you can take it and plug it back in to check your answer. Like this one, you can do 17 minus 7 equals 10, or -11 plus 6 equals -5. Or this one, you can do 2. 2 times 2 is 4, plus 6 would be 10. So no matter how far you go, you could plug in a -3 to every single one of these x's here, and you get the same number on the left side as you did on the right side. That's the whole goal of solving an equation, is to find the number that would make this equal. If I plugged in an 8 to this a and simplified it, I would get 7 for my answer. So you can always check all these no matter how far you go in math. Anytime you find a solution, you always plug it back in and check it. What if I have a problem that ends, I'm working it and I get to the last step and it looks like this right here? First thing I need to do is what? Move that 5. So now I have -x equals -12. Am I done right there? What do I do? That's like a -1, so I can divide both sides by -1 and it give me x equals +12.
Say if you have an equation that doesn't divide like equally, would you leave it as a function?
Yeah, leave it as a fraction. So you're talking about something like 7x equals 19.
Yeah.
Yeah, so like this, I just divide both sides by 7 and just leave it as, don't turn it to the decimal, just leave it as a fraction like that. I think it's the next section. Well, let's start again. Let's say I have a fraction like 1/3 x equals 5. X equals 15, correct. Okay, so when we get into the harder fraction ones, what I'm going to do, which we should talk about real quick, is find the least common denominator. What is the least common this one only has one, so it's not really finding the least common denominator. But the least common denominator is what is the smallest number that 3 will divide into, or if you had multiple ones, here. So if you multiply an equation by the LCD, it'll make all the fractions go away. We don't like fractions, so the first step we're going to do when we see a fraction is just to multiply by the LCD and make all the fractions go away. So here, if I just multiply this one by 3, the 3's cancel out, I get x equals 15. Okay. So that one you can see the answer on that one easily. But if you have something like this, the book may teach you to do it all in one step, but I'm going to teach you to do it in 2 steps, because then that will work for every problem that we have in fractions. And when we get to the end of the semester and we're doing rational equations, we're going to do the same property to get rid of the fractions. So to get rid of the fractions, you multiply by the LCD. So here, what can I multiply both sides by to get rid of this fraction? 2. Just multiply by 2. Yeah, the one step is to multiply by the reciprocal. So the 2's cancel out, and you get 5x equals 30. So what that does is that gives me an equation to work without the fractions. And then divide by 5. Okay, most people to teach probably to divide by or multiply by 2/5, and you can do it all in one step. The reason I show it like that is because when you get to problems like this, when you get a problem like this, you can't just multiply by the reciprocal. Okay, we do not like fractions. Nobody likes fractions. I believe this type of problem is actually in 2.3. Probably sneaking into 2.3 territory now. Nobody likes fractions, so let's just get rid of the fraction. Okay, so what is the least common denominator of 2, 4, and 6? That's greatest common factor. Least common denominator is what's the smallest number that all 3 of these can divide into? There's one actually smaller than 24. You can use 24. 12 do it. 12, okay, so if I multiply everything in here by 12, it'll make all my fractions go away and make it a lot easier to work. So I multiply this one by 12, multiply this one by 12, multiply this one by 12. So really what I'm doing is doing 12 over 1. So when you go to do these, there's a very, very easy way to do these. This fraction bar goes all the way across, and that fraction bar means divide. So really this is just 12 divided by 2, and you get 6x. On this one, you have 12 divided by 4 is 3, and then 3 times 3 is 9. And here, 12 divided by 6 is 2, 2 times 5 is 10. Now I have a problem to work with no fractions whatsoever, and y'all can do that in 2 seconds, okay? So first thing when you see fractions is multiply by the LCD, and it'll make all the fractions go away. Nobody likes them, so just get rid of them. So 6x equals 1, and divide both sides by 6, so x is 1 over 6. All right, so this one, again, we got to kind of work some stuff out on the left side. So we distribute the 4 and get 8x minus 12 plus 7 equals 3x plus 5. So now we can combine these, right? So 8x minus 5 equals 3x plus 5. Now there's nothing left I can combine on the left side or the right side. So now I start thinking about moving stuff across. So if I subtract 3x here, subtract 3x here, get 5x minus 5 equals 5. Then to get the x by itself, I need to add 5 to both sides. 5x equals 10. And divide by 5, so x is 2. And again, if you want to check that, you can take that 2 and plug it back in and you can work it out. You get 11 on both sides. All right, so when you're working this one, again, we got to distribute to start. So you get 16 minus 8t equals negative 5t. What should I do next?
Add 18 to negative.
Probably the easiest thing, I know most of us like our variable on the left, but since I have one variable over here, the easiest thing going to be is to move this 8t over here. So now I have 16 equals 3t, and then I can just divide by 3. Trying to get a problem worked out. What if I just like my t's on the right, on the left here, and I add 5t to the other side? Let's see if I can. So let's say I'm back at that spot, and I have somebody that just likes their t's on the left. So they add 5t to both sides here. So on this side, I have 16 minus 3t. What do I have on the right side now? 0. Okay. So that's fine. 0 is a number. So now I subtract 16 to both sides. And I have negative 3t equals negative 16. And divide by negative 3. And negative divided by negative makes that positive. So you get the same answer. Just make sure if you get rid of everything on one side, then you put a 0 there. All right, so here's this problem. Don't want to deal with the fraction, so what can I multiply by? 6. So if I multiply everything in here by 6, it should make the fractions go away. So here you have 6 divided by 2, it'll be 3x. Here's just 6 times 1. Here you have 6 divided by 3, which is 2, and then 2 times 2 is 4. And then 6 times negative 3 would be negative 18. Now I have a problem with no fractions, a lot easier to work. What's my first step? What do y'all want to do first on this one? Minus the 4x? Okay. So I subtract 4x, because y'all like the x on the left. So negative x minus 6 equals negative 18. So now I add 6. And I have negative x equals negative 12. Divide by negative 1. Or this is the opposite of x, so the opposite of negative 12 would be positive 12. So if you change all the signs here, you just got to change all the signs here. I would have, personally on that one, I would have subtracted 3x, put my x's over here, because I would have kept my x's positive. Y'all get stuck in doing it to the left, which is fine. It does not matter. No difference. All right, so here's one with the big looking fraction. But again, if I want to get rid of that fraction, what can I multiply by? Just multiply everything by 3. So if I multiply this side by 3 and this side by 3, really I can just do just 3 here and 3 here. So here these 3's cancel out. So then let's go ahead and distribute this to save ourselves a step. So you get 2a plus 6. Here 3 times 6a is 18a, and 3 times 2 is 6. So you multiply everything in there by 3. So now what do you want to do? Minus 18. Subtract the 18a. So I get negative 16a plus 6 equals 6. Now when I subtract 6 from both sides, what do I get on the right side? 0. That is okay. 0 is a number. So if you divide 0 by any number, what do you get? 0. You divide 0 by any number, you get 0. What if you divide any number by 0?
You can't.
Can't. You get undefined. Do it in the calculator, it'll pop up and say error. So 0 divided by any number is 0. 8 divided by any number, or any number divided by 0 is undefined. I think that was a Ask Siri thing. If you ask Siri about this, which is funny because it's the same example I've used in class for like 8 years now, way before Siri was ever thought of. If you have 0 divided by 16, if you have nothing and you divide it in 16 parts, you still have nothing, right? But if I have 8 cookies and I'm trying to share it with y'all in class tomorrow and nobody shows up at class tomorrow, then it's a problem. It doesn't really work. I can't split 8 into 0, right? I can't split it into 0 parts. And if you ask Siri, I think she says something about cookies, and then she says you don't have any friends. She's like, you have 8 cookies and 0 friends to spend it with, so you don't have any friends, or something like that. So you can't divide by 0. Whole point of that. All right, let me go see if there's this type of problem in there. Is anybody in 2.2 yet?
Yes.
Have you seen decimals?
Yeah, number 21.
21. Okay. All right, so on this one, I do not, again, just like fractions, I do not want to deal with decimals. So what I can do, since there's one decimal place, the biggest place is one decimal place, I can multiply by 10 and it will make all these go away. If I multiply by 10, it moves the decimal one spot. If there was a number like this, like 25, like 2 decimal spots, I can multiply it by 100, and what it would do is move it 2 spots to make it a real number. Okay. So multiply by what?
5. Multiply by 5.
You could. I mean, yeah. I mean, it would work out the same because that would become 4, right? Yeah. So I mean, you have to think about it that way. And here, all I'm doing is counting. Okay, there's 1 decimal spot on each of those, so I'm going to multiply by 10. So let's multiply all these by 10. So 10 times 0.2, we just move the decimal 1 spot, it becomes 2x. 10 times 0.8, move it 1 spot, it becomes 8x. 10 times 17 would be 170, and this would be 10. So now we have what? Negative 6x when I combine these. And add 170 to both sides. You get negative 6x equals 180. Divide by negative 6. X is equal to negative 30. All right, so I guess that's it for 2.3. Most of the problems I'm doing, I think, are harder than most of those. Longer, at least. Fraction ones, which are a pain, but just multiply by the LCD and get rid of those fractions so you don't have to look at them.